Okay, the first thing I want to do is I'm going to show the conversions from converting degrees to radians, radians to degrees, because obviously you're taking the benchmark next week. And I guarantee you there'll be one that'll be converting radians to degrees. But first, convert degrees to radians. There are only two ratios you need to remember. Here's my little sidebar. Sidebar. I didn't realize you can't. Oh, you can see that. You're either going to use pi over 180, or you're going to use 180 degrees over pi. Okay, this first one is degrees to radians, and the second one is radians to degrees. How will you remember? It's quite simple. If they give us this, and here's the question, convert the following from degrees to radians. Okay, and they give us 450 degrees. Here's how easy this is. We know that we need to cancel the unit, right? We don't need degrees anymore. We need it to be in terms of pi. Okay, if I need to get rid of degrees, I'm going to make it a fraction. I need to have degrees on the bottom so they will cancel out. So that's how I know I need to put the 180 down here. That's how the pi goes on top. Okay, so if I do this, when you multiply them, it's straight across the lines, the fraction family, over 180 degrees. Okay, first thing I know I can cancel are the degrees. Doink, doink, they're gone. Okay, now I need to prime factor 450. And I'll write prime factor. Okay, I'm going to say it's 45 times 10 because that's the easiest for me, which is 5 times 9, which is 3 times 3, 2 times 5. So I can write 450 as 2 times 3 times 3 times 5 times 5. So I'm going to go ahead, instead of 450, I'm going to write 2 times 3 times 3 times 5 times 5. Don't forget the pi is still there. On the bottom, in the chat box, anyone want to tell me what 180 is, prime factored, without prime factoring? Because you've got it in your memory.
Isn't it 2 times 2 times 3 times 3 times 5?
It is. Thank you. Who was that?
Seema.
Thank you, Seema. 2 2s. I do 2 2s, 2 3s, 1 5. Okay, and we're going to use it a lot. That's the only reason I have you guys memorize that one. So you're not constantly prime factoring that. Okay, now Doink Fest, which is what we normally do in Unit 5. I love Doink Fest. Okay, I call it Doink Fest. It's not a real math term. The reason I call it Doink Fest is because I like making noises. Okay, so when I cancel, I go doink, 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 doink. I say doink. That's why it's a Doink Fest, because you're going to cancel all this crap. You're like, why didn't they just write 5 in the first place? Okay, well, the answer is everything that's left over. This 5 is left over, the pi, and this 2. So it's going to be 5 pi over 2. That's how you convert from degrees to radians. So this is equivalent to 450 degrees. Now I'm also on the same page, and I'll put these notes out there. You don't have to necessarily, or you can take a picture when I'm done. Okay, I'm going to post this video as well. So now I'm going to convert radians, and this is what you'll see next week on the test, on the SAT. I promise you. I don't know which one they'll give you, but I'll give you one that's a little tougher. Let's go with this one. Let's try this. They're going to ask, and they're not going to ask you anything near this tough. In fact, I think they're going to ask you something like pi over 9. What are the degrees? All you have to do is put a 180 there. 180 divided by 9 is 20 degrees. Sometimes you can do it in your head. Okay, this is a sidebar. I think they're going to ask something quite simple. Pi over 9, pi over 4, 2 pi over 3. But think about it. 180 divided by 3 is 60. 60 times 2 is 120 degrees. 4 goes into 180. 1, 5, 15 times. Ooh, is that 15? Is it really? I have to do it real quick. 180 divided by 4. 4 goes in there 2 times. Remainder of 2. Yes, 25. Oh, it's 25 degrees. Okay, here's how well you do. I have pi on top, so I'm going to put 180 degrees. I need to get degrees in there. They want me to convert it to degrees, so I need the degree sign to be inside in the problem. I need to get rid of pi. So I doink away the pi right away. Okay, 25 is 5 times 5. 180 is 2 times 2 times 3 times 3 times 5. 8. If you're not sure, it's 2 times 4, 2 times 2. Hopefully you realize that 25 is 5 times 5. Okay, so on the bottom I have 2 times 2 times 2. Doink fest. Doink, 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 doink. Everything that's left is your degrees. Sorry, I was supposed to have an 18 on the bottom, not an 8. 18 is 2 times 9, which is 3 times 3. So it's going to change something. This 2 is going to come back. Apologize. I didn't write the problem down right. I was wondering why I still had leftovers on the bottom. Usually when you do this, you won't have leftovers on the bottom. Okay, so what's left over is my angle. All of these I have to multiply out. So 5 times 5 times 2 times 5. Well, I know 5 times 5 times 5 is 125. And then times 2, 250. So I get 250 degrees. I really honestly think they're going to ask something a little simpler on the SAT. Usually every year it's something it's really quite simple, but if you've never seen it, you just look at it and you're like, I have no clue. So let me take a quick picture so I can do it on my notes and then show the last thing I want to show. And then I'll have that video hopefully posted today. Well, I will, hopefully at lunchtime. Okay, last but not least, I want to make sure we can write an angle that we can identify or tell me what is the angle measure. I want it in radians, but in order to get it in radians, I'm going to suggest that we put it in degrees first and then convert. And then I'll show you also another way to do it, which some people say it's a shortcut, and I say it's a confusing shortcut. But I'm going to show both ways. The first way I'm going to suggest is let's just find it in degrees, and then convert. Okay, so remember when we go around, first of all, counterclockwise is positive. And you're like, that's backwards, Miss Sweat. Well, think about when you first learned how to find angles. We would draw this and you would measure it and you say, oh, that's 30 degrees. Guess what? You were doing counterclockwise. Okay, and clockwise is negative. So when I look at this one, I'm going clockwise. So this is going to be a negative answer. I don't know what it is, but I know for sure it's negative. So I'm just going to put my negative sign over there and not worry about it for right now. I'm going to start here and I'm going to go around. Oh, I went a full rotation, 360 degrees. Some kids have asked, why don't they just make a full circle? And here's why. If I come here and I go around once, you're like, oh, okay, that's 360. I go around twice, 3 times, 4 times, 5, 6. How many times did I go around? You can't tell because the line just got darker. You have no idea how many rotations I did. That's why they offset these. Okay, now I'm going to continue. I'm going to go again, and I did one full rotation, 360 degrees. Now I need to determine what is this. And they tell me it's 2 pi over 9. Well, guess what? I'm going to convert 2 pi over 9 into degrees. It's this simple. Take out the pi. Put in a 180. And this is why, because I'm going to multiply by 180 over pi, right? The pi's are going to cancel, so I'm really just substituting it. Pi is equivalent to 180 degrees. 2 pi is equivalent to 360. If you ever get confused why, when you go to find circumference of a circle, 2 pi times the radius. 2 pi, it's the whole circle. The reason we multiply times the radius is we don't know if it's a skinny circle, a fat circle. That's why we have to multiply times the radius.
Okay. Isn't the radius also like half the circle too, like the midsection?
It's
like
half of the diameter, halfway across. Yes, yeah. Absolutely. Okay. But that's not why it's 2 pi. It's 2 pi for the whole circle.
Yeah.
Okay, got it. Yeah. All right. Anyway, so I will look at 180 divided by 9. 9 goes into 18 twice. So this is 20 degrees right here. 20 times 2, I get 40 degrees. Okay, so I need to add that in. So 0, 6, 12, 13, 14, 15, I get 16. I get 760, but I don't want it in degrees. And how do I know I don't want it in degrees? It didn't say. Well, here's how you know. If the clue that they give you is in radians, your answer is in radians. So I'm going to take 760 and convert it. I'm going to multiply it by pi over 180. I'm going to go ahead and prime factor 760. It's 76 times 10, 2 times 38, 2 times 19, 2 times 5. So I've got 2 times 2 times 2 times 5 times 19 times pi all over 2 times 2 times 3 times 3 times 5. 2 2s, 2 3s, 1 5. Doink fest. Doink, 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 doink. Anything left over is your answer. Okay, so I have 2 times 19, 38 pi over 3 times 3 is 9. Remember, it was negative at the beginning, so you simply put a negative there.
So is that the total? That's the total.
This is the final answer. This is 760 degrees converted to radians.
Okay, thank you.
All right. Now, I will also take a picture of this for my work, and then I'm going to show the other way. And Jazzy, I'm going to tell you, turn off your mic or turn off your speaker. I don't think you're going to like the shortcut. And you don't have to like. In fact, I'm almost tempted not to show it, guys. I'm going to show the shortcut, and I'm still recording. Tell me why this is a bad move, because I know deep in my heart it's a bad move. All right, here we go. Because I've done this a time or 5. All right, we already know what we were writing here. We had 360 because we did one rotation, right? Okay, I'm going to do this again. And then 360 because we had another rotation. And then I'm going to go ahead and just leave this 2 pi over 9 for the orange, which we figured out to be 40 degrees. Although we know that's equivalent to 2 pi over 9. What I'm going to do here is write this in radians. Okay, well, we know that 180 is equivalent to pi. 360 is equivalent to 2 pi. So every time I see 360, guess what I get to write? Yep, 2 pi. There's another 2 pi. And now I have 2 pi over 9. Well, so I've got 4 pi because of these two. And I need to add 2/9 pi to that. So I need to find a common denominator. Yes, you got to use a little bit of fractional stuff. Put that over 1. Let's multiply this by 9 over 9. So I get 36 over 9 pi plus 2 over 9 pi, which will be 38 over 9 pi. And we have to put negative because it went clockwise. So we knew it was negative because of the clockwise. And to me, it is a shortcut, but some people don't like fractions. So if you don't like fractions, you don't even want to look at the shortcut. Okay, I'm going to stop my video.